Hi, today I'm going to show you how to solve problem 27 from the 2018 Math Kangaroo grades 5 to 6. Here's the problem. Write 0 or 1 in each cell of the 5 by 5 table so that each 2 by 2 square of the 5 by 5 table here contains exactly 3 equal numbers. What's the largest possible sum of all the numbers in the table? So we have 2 by 2 squares here. So for example, this is a 2 by 2 square. And there's others too. There's one here, and a 2 by 2 square in this table has to have this property. And some of the 2 by 2 squares are going to overlap. For example, there could be a 2 by 2 square here that overlaps with this first one. And we know that for any of these 2 by 2 squares, there's going to be exactly 3 numbers in it that are equal. So for example, if we look at this one, we could write 0, 0, 0, 1, and then it has 3 equal zeros. Or we could have 3 equal 1s, and we could have 1, 0, 1, 1. It doesn't matter what order they're in, as long as we have 3 zeros or 3 1s. But we do know that we're trying to maximize the sum of all the numbers in the table. And 1 is greater than 0, so more 1s will give us a bigger sum than more zeros. So we do want to have as many 1s as possible in the table, because that's going to make our sum the biggest. So if we had all 1s, that would give us a sum of 25, but we can't do that. We have to have at least sub-zeros, because we know that each 2 by 2 squares has to have exactly 3 equal numbers. We can't have 4. So 4 1s isn't an option. So we want to have as many 1s in the table as possible, and we're going to do that by making sure each 2 by 2 square has 3 1s and a 0. So if we start with this square, well, we could put a 0 here and then 1, 1, 1. But this actually isn't the most effective way to do it. And that's because this 0 is in the corner, and it's only in one 2 by 2 square. And if we put it in a place where it's in other 2 by 2 squares also, in 2 by 2 squares that would overlap, then that 0 could be the 0 for all of those squares. So we wouldn't have to have extra zeros for that. And we want to minimize the number of zeros. So for example, if we were to put the 0 here and the 1 here, well, then we could see that this 0 would be the 0 for this square and for this other square I drew here. And the same would be true here. It would be for this square and this square. But if we put the 0 here, that really maximizes it, because we see that this 0 would fit for this square, this square, this square, and this square. We can't have there be a 0 that is in more than 4 squares, because there's only 4 different positions in a 2 by 2 square that the 0 could be. So we know this is the most number of squares we can get the 0 to fit in. And now if we look at these squares, everything else can be a 1. So we can have a 1 here, and here, and here, and here, and here. So that's a lot of 1s for only 1 0. So that's good. We want to keep doing this. If we look at this side, well, we can do the same thing. If we move this over and we have a 0 there, that would also work for these 4 squares, and we could fill in the rest with 1s. That would give us a lot of 1s. So let's put a 0 here, and we can fill in 1s all the way there. And if we go to the bottom half, again, we could put a 0 here, which would work for these 4 squares, and we could put 1s around, a 0 here, and put 1s here. Now we filled out the square, and we can just double check that we've followed all the rules. So if we start and look at this 2 by 2 square here, this first one, well, we see we have 3 1s and a 0. That's good. If we keep going along this row to this one, we have a 0, 3 1s. That's also good. That's according to the rules. If we move over to this square here, there's 3 1s and a 0. That works. Here, there's also 3 1s and a 0. Now we'll go to the next row of squares. That would start with this square. We have 3 1s and a 0. Here, we again have 3 1s and a 0. Here, there are 3 1s and a 0. Here, 3 1s and a 0. Here, in this third row here, we have 3 1s and a 0. Here, 3 1s and a 0. Here, there are 3 1s and a 0. Here, this square, we have 3 1s and a 0. And in the last row, we start with 3 1s and a 0 in this square here. Then we have 3 1s and a 0 in this square, 3 1s and a 0 in this square, and 3 1s and a 0 in this square. So this is an arrangement we can have because it works for everything. We know that this is the maximum number of 1s because each square only has 1 0. There's no way we can make it have less, and the zeros all overlap in 4 squares. So now all that's left to do is find the sum of all these numbers, and so that's just the number of 1s since the zeros don't add to the sum. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 1s in here. So the sum of all the numbers is 21. And the answer is B. Thank you.